Greetings, my name is Andre Ceresari, and this is a general overview of the features on the mobile ultrasonic test equipment. First, I'll start with the drive system. The system incorporates a two-wheel drive. It has idler wheels on the front and the back, which are multi-directional wheels, which make it easy for the robot to spin on one axis. The gearboxes include a worm gear, which make these wheels non-back drivable, so the only drive that can happen is through the motors and not by any other motion outside of the wheel. The gearing system was made at a 90-degree angle to provide a good spacing for equipment such as the battery, the coupling bag, and the speed controllers. Next is the brief overview of some of the electronics equipment. The electronics equipment is mostly housed inside the electronics bay, which lies towards the front of the robot above the rail. Here we have equipment such as the C-scan card, the programmable logic controller, and external to the electronics bay we have items such as the battery pack and the speed controllers. Specifically, the battery pack consists of 8 rechargeable D batteries. Each is at 1.5 volts, and at 8 batteries in series they become a 12 volt set, and then there's 4 packs of these 8 in parallel to provide the necessary amperage to power the robot for 1 hour. And also, again, the speed controllers are mounted outside the electronics bay. Next is the scanning slider, which is the main system used to populate a C-scan matrix. As you can see here, the transducers are placed on the outside of the slide, and this is the general process for filling the C-scans matrix. So the system takes one set of scans simultaneously. Here it takes 6 scans. It moves over, and then it takes another set of scans, and it progressively populates the area until it gets to this one specific area, and then it makes a larger step forward. If any flaw is encountered, it is marked down in the matrix as a flaw. The transducer system incorporates a coupling guide, which is used to fill in the area under the transducer with coupling to make sure that the system is always able to properly transmit an ultrasonic signal to the test piece. A couple pieces of equipment that are necessary here. Here we have a linear actuator, a spring which allows this outer coupling guide to move upward once this transducer is coming down, and then this specific area right here, this gap, and you can see the gap here too. This is where the coupling will be filled, and then any excess coupling will be ejected out of this corner. The system to keep the robot in place on high angle inclines is an optional and modularized normal pressure system. Here this is powered by a linear actuator which provides a pressure onto this bracket. This bracket was placed here so no horizontal forces would be placed on this linear actuator, so the only motion that the linear actuator would take would be along its axis. Here on this system, the center wheels will be providing the friction. Here is a diagram of a free body diagram of the robot inclined at 90 degrees. The cables will be holding it into place, and then the normal pressure will be pushing this wheel against the surface, and the friction will be providing the upward force along with any additional force as that comes from the cable here if required. This particular forces can be a flaw. When the robot is moving above half the cable, this will become a force that will be downward, and the robot will then have the capability of tipping, which is unwanted. And this is a general overview of the features on the mobile. These wheels non-back drivable, so the only drive that